Okay, so welcome back, and now we're going to do an example of a trigonometric equation that we want to solve. Now they want all possible values, all possible solutions for this trigonometric equation. So in other words, we want to find all the values of theta that will cause this cosine of this angle to be 1/2. So a couple of things again to think about as you're looking at this. Again, you can use the unit circle, and so if you know it, we know, like just by looking at it, we know that cosine theta is 1/2 only in 2 quadrants, right? Because it's positive. We know cosine is only positive in the first and the fourth quadrant. So we know that on the interval from 0 to 2 pi, from the interval from 0 to 2 pi, we know that the only 2 angles that will give us that are pi over 3 and 5 pi over 3. So again, if you come over here and just look at the unit circle here, right, we know that we get a triangle here, right? And we get another triangle here, right? And so if you think about the triangle, then we know that what's the cosine? It's opposite over hypotenuse. Or excuse me, I'm sorry, adjacent over hypotenuse for cosine. So it's going to be 1 over 2. Well, that means that this here is going to end up being the square root of 3. Again, do the Pythagorean theorem, right? So we've got 1 squared plus x squared equals 2 squared. And so this is going to be 1 plus x squared equals 4. And so if you subtract 1 from both sides, you get x squared equals 3. And that's where you get x equals the square root of 3. And this is positive, right? So if we're in the first quadrant, this is positive, right? Okay, so now, so we know by looking at this, this is a 30, 60, 90 triangle, right? So again, if you either know it or you can figure it out by figuring out the triangle and then noticing, oh yeah, this is a 30, 60, 90 triangle, and this is a 60-degree angle, which means it's pi over 3. And if it's pi over 3 here, then if I go all the way around to the fourth quadrant, it's going to be 1, 2, 3, 60-degree angles here, and then 1, 2. So that's going to give me 5. So that's going to be 5 pi over 3, because I'm taking pi over 3 and multiplying by 5 to get around. And again, I'm just walking you through that. You might already know that, but if you don't, just remember there's ways of figuring this out. Okay? So if you know it, just by thinking about it in your head, great. If not, then you can go back to the unit circle and figure it out. Okay? So we know on the interval, so right away, just by using the unit circle, we know on the interval from 0 to 2 pi, there are only 2 places or 2 solutions. Okay? And that's going to be pi over 3 and 5 pi over 3. Okay, and now this is pretty much most of what you have to do, because now the thing is they're asking you for all possible solutions. So we just have to know how to write it so that it takes care of an infinite number of solutions. So since this is the only solution within this interval, so we're going to use this one and this one separately. Okay? So that means every 2 pi, this is going to repeat, and every 2 pi, this is going to repeat. So the way we write the solution set is going to be this. Theta equals pi over 3 plus or minus 2 pi times k, where k is an integer. Okay? And then the other and, right? We're going to have and theta equals 5 pi over 3 plus or minus 2 pi k, where k is an integer. And so this would be the solution. And that's it. Have a great day.